Hello everyone, myself Rajeev Physics faculty. So, my dear student, how are you? Fine? Okay. Today we are here to discuss a special topic on a special demand. Today we are going to discuss integration. This was demanded one of my students. So let's see, today we will study what is integration and what is its application. So first of all, I am writing what we are going to do a study. Listen. In integration basically we will study three topics. First, introduction. Okay, first what? An introduction. Second, formula, and third, application. So listen, third, application. So these three topics, subtopics in integration we have to study. So we are going to start one by one. First of all, we are going to start introduction. Okay. So just see what is introduction. See what is the meaning of integration. You know meaning of differentiation? Okay. Just I am telling you. Suppose this is our one rod. Right? This is our one rod. And you have to divide this rod in many small parts. Remember, if you have to divide this rod in many small parts, very small parts, then for this we should use differentiation. It means for the process of division, we can use mathematical function that's called integration. That's called differentiation. Now see, this is a one. Suppose like a small object. This is another small object. This is another. If you have add all these small objects, then we should use a mathematical function of integration. Getting my points? Again I am telling you. See what I told. Suppose this is a one rod and you have to divide this rod in many small parts, very small parts. Then for this you should use a mathematical function. That function is called differentiation. So what we can say, for division we can use one kind of mathematical function. This is called differentiation. Suppose we have one very small object, another very small object, another very small object, another very small object. For addition of all these, we should use one mathematical function. This is called integration. So here we can use integration and here we can use differentiation. So I think this is clear, my dear. Yes or no? One more example too. No issue. Take one more example. See. Suppose that I can write this one. Okay. Just to be conscious. Sorry. Just pay attention. See here. Suppose that this is a road. This is a what? Road. Okay. Right. 0 and length L. Suppose that width is T. From here to there, we have distributed marbles. Okay. See, we have on road which length is L and width is T. We have distributed lot of marbles. If I am asking to you, count the number of marbles. Suppose road length is 200 kilometers. And I am asking to you, count these marbles. Are you capable to count? Yes, you are capable to count. But this is a very long process. This is a very long process. To remove this long process, to reduce the time of consumption, we will use here integration. How? We will move at x distance. See here, we will move at x distance and we will take a small thickness dx. Try to understand. We will move at x distance and we will take a small thickness, a small length dx. Now I will count number of marbles in this length, in this area. Now I will count number of marbles in this area. So what is this area? dA is equal to T into dx. Suppose that in that area number of marbles is dn. Suppose that in this small area number of marbles is dn. Now we can say this road is made up like that, lot of a small area like that. See, now we can say this road is made of lot of a small area like that. Now we have to add number of this one, number of this one, number of this one, number of this one, number of this one till here. It means in a small area dn and we have to add. So total n is equal to what? Integration of dn. Getting my point? So if you will do integration of this one, you will get the total number of marbles. Getting my points? So these are the introduction. In this place, we will use function of mathematics, which is called integration. Getting your points? Now coming on the definition. So see its definition, sir. What is the definition? It is a mathematical function. What? It is a mathematical function which is used to add. This is a very important point. This is a method to getting the addition, sum, add infinitesimally a small infinitesimally value, or you can say infinite very small value over large area, large surface, large volume, large length. Just I took one example. On the road marbles are distributed. So how we will count the number of marbles? So here you can see marbles are distributed up to 1000 km, 250 km, 200 km. So here marbles are distributed over the large area. So what we can do? First of all, we calculate marbles in a small area and then we can integrate. Get my points? Okay. Is there any issue? No issue. See, right. Come on the next point. Now see here, symbol of integration. You know symbol of differentiation. Just like symbol of differentiation, we have symbol of integration also. We know that differentiation represented like dy by dx. Similarly, integration can be represented by this symbol. This symbol means you are going to do integration. Suppose someone wrote like this: integration f of x dx. We can read this one: integration of f of x with respect to dx. Getting my points? And this one will represent variable. This one will represent variable. Suppose dx, it means what? X is a variable here. If another variable, another like y, z, t is available, then we cannot count those are the variable. We will count only these are the variables, right? So this will represent variables. Getting my points? So this is the symbol of integration, and this is we can read like integration of f of x with respect to with respect to x. Sorry here. Okay, can I take another part? Okay, see here the most important point. What I wrote here, read this statement. Integration is reverse process of differentiation. My dear, see here. Integration is reverse process of differentiation. So that it is also called antiderivative. Integration is reverse process of differentiation, so that it is also called antiderivative. Now take one example. Suppose that y is a function of f of x. Y is the function of x. So we can write here y is equal to f of x. But here f is capital. Keep this in mind. Now differentiation of this one, I assume becomes a small f of x. I assume, because we are taking one example to getting the understanding, to get understand. So I just took here capital F of x and its differentiation become a small f of x. So what the mean of reverse? Suppose that you have getting anything due to differentiation. If you will do the integration, you should again get the original quantity, original function. So see, now I integrate to this one. I got here original function. Because of that, integration is said that reverse of differentiation or antiderivative done. It means anything you got at the differentiation, you use the integration, you will get the original function, original mathematical equation. Just see. So just see, we can remember like that. Differentiation of f of x, a small f of x. Integration of a small f of x should be capital F of x. So this is called differentiation. So I think you got it each and everything, what the meaning of differentiation, what is the relation between integration and differentiation. Now we are going to discuss formula of integration. Then we can use another quantity like types of integration, numericals and all these things. So see, first of all, okay, so see, the first formula is called, my dear, the first formula is called power formula. Suppose that y is a function of x power n, y is a function of x power n, then we can write the integration of this one, x power n dx. This result becomes x power n plus 1 by n plus 1, n plus 1 by n plus 1 plus c. C is called integration constant. Now you can ask, sir, why here C you have added? I will prove and I will give you clear explanation why I added C here. But for this bit, when I will take types of integration, definite and indefinite, in that case, definitely I will teach you how we can add C here. What is the reason behind this one? Till now, till date, you have to wait. See here. So integration of x power n dx become x power n plus 1 divided n plus 1. But here n should not be minus 1. N should not be minus 1. Why? So n should be minus 1, then minus 1 plus 1 becomes 0. So this becomes undefined, right? Getting my points? Function becomes undefined, invaluable. So we cannot take n is equal to minus 1. So first of all, we are going to take some example based on this one. See, now see, we have one function 1 by x squared dx. Now this symbol is saying that you have to integrate. Now this one is saying that this is a variable. So what we can do, we can write this function like that, x power minus 2 dx. We can write yes or no, tell me, x power minus 2 dx. Now this becomes function of, my dear, compare, now this becomes function of x and dx, right? Yes or no? So compare to this one, here n and here minus 2, it means n is equal to what? Minus 2. So our answer becomes integration I is equal to x power n. N is what? Minus 2 plus 1 divided n plus 1. Or I told add plus c. So this become here x power minus 1 plus c. So this become minus 1 by x plus c. This become minus 1 by x plus c. Getting my points? Okay. So this is the integration of first function. This is the integration of first function 1 by x squared dx. Getting my points? Next. Now see integration of this one. 1 by root x dx. So again we can convert this one in power form. This becomes x power minus 1 by 2 dx. Yes or no? So just n is equal to what? Minus 1. So this becomes x power minus 1 by 2 plus 1 divided minus 1 by 2 plus 1 plus c. So this becomes, my dear, c x power 1 by 2 divided 1 by 2 plus c. So this becomes 2 root x plus c. Getting my points? Okay. from here we can make one result. See this formula and this formula. If you will see this formula, then we can make another one formula, my dear. Integration of 1 by root f of x dx. Integration of 1 by root f of x dx. Okay, anybody tell me what should be differentiation of x? Yes, anybody tell me what should be differentiation of x? Differentiation of x is what? 1. So here 1. So what we can say, differentiation of x divided this one into this one is equal to this one. It means we can say here, if like that, see here, differentiation of function divided under root f of x, this result should be 2 root f of x dx, plus c. This should be result. I will try to clear this one taking one more example. So just wait and see. Now see, we have one example here. 2x divided under root x square plus 3. How we can integrate? So I told the second formula. You have studied. You got the second formula. Second formula is what? If in numerator f dash x, f prime x, f dash x or a prime x called differentiation. If in numerator differentiation and in denominator under root function, then we can directly write integration to root function, right? So see, what is in the denominator? This one. So I assume this one f of x. See, f of x is equal to what? X square plus 3. Now find f dash x. F dash x means differentiation of this one. So differentiation of this one becomes 2x, 3 becomes 0. It means this is what? Its differentiation. So I assume this one, so this function become like that. See here, this function become like that. 2x. It means this become f dash x. This become under root f of x dx. And this is our second formula. On the basis of second formula, we can write this one directly 2 root f of x plus c. So this becomes 2 root f of x from here, x square plus 3 plus c. This becomes our result. Yeah, for this we can use another method also, that is called abnormal method. I will teach you later. So just now see this one. Getting my points? One more question. See, you have to find integration of this one. Can you use this one? Yeah, simple. You can use power method. Just convert this one. This become what? X power 1 by 2. So you can get the result from here. Yes. So I am leaving this question for you. Next, see constant multiple function. See, we are going to discuss constant multiple. Constant multiple means any function which is multiplied by some constant. I assume this is a function f of x and this is multiplied by some constant c. In that case, if constant is there, then we can take that constant outside the integration. So this result will become like that, c outside. And now you have to integrate to only f of x. Getting my points? So you can evaluate your question like that. Just take one example, like suppose that 2x square dx. So I can 2 take outside. Now we can just differentiate this one x square plus x square dx, right? So what is the integration of this one? You can use by power formula x cube by 3 plus c. So this is the result. Getting my points? This is called constant multiple result. Now coming on another points, addition and subtraction. See, if you have integrate like function like that, f1x plus minus f2x. So simple, you can separate this one. This become f1x dx plus minus f2x dx. Getting my point? And at last you should add one integration constant c. Again I am telling you, I will teach you how this come and why we have to add here. Get your points? Oh, just wait. So see one question based on this formula, then we will move. See, we have this result. Oh, sit. Okay, basically, the mobile fall down. Okay, no issue. See here, we have this result, this formula, and after then we got it one question. This question is what? Integration of 2x plus x squared dx. So you can see here more than one function. This is a one function, this is another function. So first of all, separate this one, write this one like that. 2x dx, in between them plus, so plus here, x squared dx. If there is minus, so I will put minus, but here plus only, so I will put plus. Now see, this become your ordinary case. This is what 2 into x, 2 is what? Constant. So 2 outside, this become x dx. Plus, you can integrate this one, why? By using power rule. So its power is what? 2. So resultant power become 2 plus 1, 3. Because n plus 1. And here n plus 1, 3. Plus some constant c. Now see, this is a 2. Its power is what? 1. So 1 plus 1, 2. So this become x square by 2 plus x cube by 3 plus some constant c. So result is coming x square plus x cube by 3 plus c. So this is a result will be. Getting my points? Suppose that if there is a minus, so we can use the same formula. So till now we got 3 results. First, power method. Second, constant multiple. Third, addition and subtraction. Now let's move further. Okay, anybody tell me what should be integration of dx? Can you tell me what should be integration of dx? Okay, you are not getting. Okay, what we can write? We can write this one. 1 into dx. Is there any problem? No problem, sir. Okay, we can write 1 is equal to x power 0 into dx. We can write yes or no. So here we got the formula x power n into dx. What the value of n? N value is 0. So result should be what? Then the result should be x power 0 plus 1 divided 0 plus 1 plus c. So this become x1 by 1 plus c. So this become x plus c. Getting my point? This become x plus c. Similarly you can write integration of dy. So from here you can say y plus c. Yes, tell me integration of dt. Simple, sir. T plus c. So this is also very important. You have to keep in your mind, right? Getting your points? Only I am taking those formula of integration which will be used in physics. Otherwise, if you